Today's lesson marks the beginning of our next unit. So we have a couple of units left that we're going to squeeze in between now and the end of the school year. This unit, the theme of the unit is square roots and triangles. And if you're thinking, that seems kind of a random combination, they actually are related. They have some connections, and you're going to see what the connections are by the end of the chapter. But if we're going to talk about square roots and triangles, we should probably start by talking about square roots and getting you up and running with working with square roots, because you're going to be working with square roots a fair amount in this chapter. So that is the goal of today's lesson. So first of all, what is a square root? So a square root, this is the official definition, and then you got a whole bunch of examples we're going to do in just a minute. A square root is one of two equal factors of a number. So remember, factors are the numbers that you can divide a number by. So you've got this whole list of factors. So the factors have to be the same. So if my factors are 2 and 2, then the square root is one of those. They're both the same. So it doesn't matter which one, 2. So 3 and 3, it would be 3. 4 and 4 would be 5. So those are square roots. So the factors are whole numbers. Then we get things called perfect squares. And we're going to look at what's the difference between a perfect square and a square root in just a minute. Because you could have factors that are not whole numbers. You could have 1.5 times 1.5. Those are not whole numbers. So if you have whole number factors, when you multiply them together, the numbers that you get is called a perfect square. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and it keeps going down the list. So those answers you're getting, those are called perfect squares, because it's what you get when you square a number. You're multiplying it by itself. So if we track down the list really quickly, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12. Now these last ones we're getting into some that some of you guys might not know as well, but they're ones that you should memorize. So if you don't already know these up through 15 by 15, then you really need to memorize them because it's going to come in handy. So a 13 times 13 is 169. 14 times 14 is 196, and 15 times 15 is 225. So those are perfect squares. So a perfect square is what you get when you take those duplicate factors and you multiply them together. Now, the square root is one of those two factors. So I'm actually going to start with the second one because it'll make more sense. So a square root has its own symbol. So if you're going to do a square root, it would look something like this. So you've probably seen a square root symbol before. It looks like this, and then it's got a number under it. So that number is what you're finding the equal factors of. So you basically, if you've got a 4 sitting there, what you're trying to figure out is, okay, what two identical numbers could I multiply to get 4? Well, we know that that's 2 and 2 because it's listed out over here. So the square root of 4 is 2. So we only list one of those factors. So it's basically going backwards from a square. So you guys know that adding and subtracting are inverse or opposite operations, and multiplying and dividing are inverse or opposite operations. So you guys probably know about squaring, which is multiplying a number by itself. A square root is basically the inverse operation from a square. It's what happens if you unsquare a number. So we could go through this whole list. So the square root of 9, 3. Square root of 16, we were to unsquare the number, is 4. So it basically puts us back to one of the two factors. And then we can keep going down the list. The reason why I skipped 1 is because it's harder to see the numbers, because the square root of 1 is just itself. And then dot, 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 I think you get the idea. It keeps going. I want you to go ahead and finish this list. So if you need to pause the video to finish the list, then go ahead and do that. But in the interest of not having the video run super long, I'm going to let you finish that off because I think you probably have the idea with those examples of what a square root is. Now, something interesting about a square root, and it's not written in the table, but it's something to be aware of. So square roots can be positive. So sometimes You might have, something like this where it very specifically says the positive square root of 9. Well, that would be 3. Square roots can also be negative, though, because you could square a negative number. So maybe if it's asking for something like this, if you have a negative outside of a square root, it's basically what that means is what negative number times itself would give you 25. Well, that would be -5 because a negative times a negative still makes a positive. So square roots can also have negative answers because a negative times a negative makes a positive number. Now, you can never have a negative perfect square. So that would be worth noting. So remember, perfect square is the number that you get when you multiply the numbers together. So perfect squares can't be negative. Because in order to get a perfect square, you have to multiply a number by itself. And there is no number by itself that would give you a negative answer. The only way to get a negative is a negative times a positive, but those aren't the same number. So it's not a perfect square because you're not multiplying the same number by itself. So perfect squares can never be negative. Now, the answer to a square root can be negative. Like we said here, a perfect square of 25, I could get by doing -5 times -5. Or it could ask you for both versions of the answer. So square roots could be positive, negative, or both. So you might see what looks like a little plus minus, and that basically means give both. So if you saw something like this, then you would give two answers. You would say, okay, 8 times 8 gives me the perfect square 64, and -8 times -8 also gives me the perfect square 64. So there's actually two different ways to get every perfect square, a positive times a positive or a negative times a negative. Those are both multiplying by themselves. Now, hopefully, kind of getting the idea of perfect square, square root. Now, perfect squares are when we have nice, pretty whole number factors. 1 times 1, 2 times 2, 3 times 3. Those are whole numbers. So that means if we go backwards, so like the square root of 36, we know that 6 times 6, those are whole numbers, makes 36. So that answer would be 6. But sometimes you don't have perfect squares and you're asked to go backwards from a perfect square. So we need to talk about, well, how do I do that? So you might have something like this, the square root of 39. Well, 39 is in between highlighted the wrong one. 39 is between 36 and 49. So the answer is going to be somewhere between 6 times 6 and 7 times 7. So because it's bigger than 6, because 36, square root of 36 is 6, but it's smaller than the square root of 49, which would be 7. So that means that the answer to the square root of 39 is a decimal. It's somewhere between 6 and 7. So there's actually a process that you can go through to get a pretty accurate estimate of where a square root's going to fall. And this is a process that you should be familiar with. So we're going to walk through with this square root of 39 and say, well, okay, great. So if it's not one of these nice, pretty whole numbers from my table, how do I still figure it out? So the first thing we want to do is figure out the perfect squares that the number lies between. So we just did that. We highlighted it in the table. So 39 is not a perfect square, but it's between 36 and 49. So you've got some space here. What we're going to do is we're actually going to, and it's going to help us with this next one. We need to count the distance between the two perfect squares. So if you think of putting the two perfect squares on a number line, so here's 36, 37, 38, 39, 40, and we're going to keep going until we get up to 49, which is the next one. I'm going to have to make my number line just a little bit longer. So 47, we're almost there. 48, 49. So there's our two perfect squares. So if you were to count that out, or you could also just subtract 49 minus 36, but if you have to figure out how far apart those are. So you can literally count it out on a number line. You can just subtract it. but they're 13 apart. So what we're going to do is we're going to come up with a fraction, and you're going to see what we're going to do in that fraction in just a minute. But we want to count the distance between the two perfect squares. So that distance between these two perfect squares that we found is 13. So now what we're going to do is we're going to see, okay, well, how far over from the beginning of this little number line that we made are we? So square root of 39 is right there. So the next step is count the distance from the smaller perfect square to the number. So basically, we're measuring this distance. So that's what this step is doing. So I'm 3 over from my smaller number. So what we're going to do is we're going to make that into a fraction. So 39, if you think about fractions on a number line, so this number line we just drew between our two perfect squares has 13 spaces on it, and I'm 3 of those spaces over to get to 39. So that's 3/13 of the distance from 36 to 49. So that's why it's saying, you know, make this the denominator and make this your numerator. So what we're going to do is we're going to say, okay, I am 3/13 of the distance over. And you have to remember that the square root of 36 is 6. So basically, I'm 3/13 of the distance over from 6 on my way to 7. So this x we marked on the number line, if we wanted to represent that as a fraction, because remember, these are actually square roots that we're keeping track of, would be 6 3/13. So if you think about throwing your square roots on a number line to see how far apart they are and what fraction of the distance are you over between the lower one and the next one, then you can get a fraction that represents that. So square root of 39 is about 6 3/13. And if we're estimating, then it's okay to round this if you wanted to change it into a decimal. So like I could say, if I'm estimating, we don't have to be perfectly accurate. So if I wanted to get a decimal estimate for this, 13ths are kind of hard to do in your head, but if I round this to 6 3/12, which is really close, 3/12 reduces down to 1/4, so that would be about 6.25 or 6.3 if you wanted to go to the nearest tenth. So basically what we just figured out is that about, not perfect, but pretty darn close, about 6.25 times 6.25 would give me 39. That's what we're figuring out. We're basically, when we do the square root of 39, we're figuring out what thing times itself would give me an answer of 39. It's not a whole number, it's a decimal, but that gives us an estimate. So what you have mapped out in your notes is literally your step-by-step process that you could go through. So you could go through these exact same steps with a different square root that's not a perfect square and get a decimal estimate. And you're actually going to try that on your assignment today. It's going to be a good check-in for you to make sure that you're understanding this process of how to estimate. So your assignment today is just going to be a little bit of practice with this idea of square roots and perfect squares and how do I get a quick estimate if I don't have a perfect square. So when you're ready, you can go